But yeah, it sounds like you're doing great. I saw you're also doing podcasting, which is super fun. I'm excited to see what you put out.
Yeah. I think it's something that we're experimenting with. I always joke, even like my little like trailer I put out, that it's like, all right, we don't need like any more podcasters, but it's like we do. We just need the right ones. We don't need the ones like saying the same like recurring content. But hopefully with kind of what we're doing, and I think what you're doing, there's this like small niche, this like door opening of this kind of like Bitcoin renaissance, like the real stuff where it's like, whoa, like we're actually going to create some sort of innovation here, and maybe that is like novel and new content.
I think it is. I mean, I feel like the reason why I'm doing this, and I imagine you're doing the same, is there's definitely not a lot of technical content that's accessible for folks, and not a lot of content that's covering specifically the sort of like Bitcoin season 2 landia. Speaking of, so we're going to get into zero knowledge proofs, BitVM. There's a handful of companies, including Alpen Labs. Just for folks who are watching, for catching you up, you're head of eco at Alpen Labs, I believe, right?
Yeah, that's right.
Okay. So yeah, super excited, big representative of Alpen Labs. There's a handful of companies that are building these sort of zero knowledge proof BitVM style solutions. They're all kind of unique and different from each other, but this is sort of a meta, I think, that's happening in Bitcoin season 2, but also maybe has some roots in Bitcoin season 1. Where do you think that this style of technology lands in that conversation?
Yeah, I mean, I guess it's a hybrid. Like I always go back to a lot of these ideas were really discussed early on in Bitcoin. Like the ideas of zero knowledge proofs were brought kind of by Eli Ben Sasson back in like 2013. The idea of like side chains were in 2014. And now fast forward, like the long short of it is we're basically taking the concept of side chains and hacking in ZK verification using ordinals. So it kind of like touches on a little bit of everything.
Let's get into a little bit of the history of zero knowledge proofs.
Sure.
So you said zero knowledge proofs as a potential use case for cryptography on Bitcoin specifically was introduced in 2013. At that point, how was it introed?
Yeah. So my understanding is, because I'm not like deep into the field, but I think the idea of like zero knowledge proofs first were invented in academia, I think back in like the 1980s. And I don't know if there was like a proper use for them, or they were just like extremely inefficient. It wasn't until much later on in like 2013 when I had mentioned Eli Ben Sasson, who's like the founder of Starkware. He went to a Scaling Bitcoin conference. I think it was like the first Scaling Bitcoin conference, and he kind of presented this idea. And some of the OG devs, people like Greg Maxwell, et cetera, said, hey, like this is cool. We could implement this stuff as soon as possible. And I think at that time it was still a bit impractical, but it kind of like kickstarted this idea that hey, like there might be this really nice collaboration between this academic idea of zero knowledge proofs and like blockchains. And then in 2016, Eli Ben Sasson was one of the founders of Zcash, which is a way to do like, fully shielded or private payments on top of a blockchain. And the way that essentially works is a zero knowledge proof is the ability to prove that something is valid without revealing the underlying contents. So in the context of payments, if you, Isabel, want to pay me 1 Bitcoin, you're able to just submit a proof that proves the validity of that payment. That's proving that you did in fact have one Bitcoin, that you did in fact sign for that using your private key, and that it was sent to me. You can prove that that payment is valid, but on the blockchain, you're not actually seeing that it was you who sent it to me or the amounts, etc. And the way we can kind of think about that is like in Bitcoin, there is this idea of like, don't trust verify. And there are a couple different ways that you can interpret that. But one thing is, it's like if somebody tells you your balance in Bitcoin, say, you have 5 Bitcoin, it's like you don't trust a banker or someone else to say that you have 5 Bitcoin and that we have it backing. Like what you do is you verify by like you run a node yourself, and that node is downloading the Bitcoin software, and it's downloading every single historical transaction from the genesis, from January 3rd of 16 years ago today to the date when Satoshi first mined the Bitcoin transaction, first block, and got 50 Bitcoin. And then you're tracing all of those blocks and all those Bitcoins ultimately to the end. You're essentially brute forcing, proving that the balance that I now show on my Bitcoin wallet is actually valid. That's the brute force way that you do it in Bitcoin. With zero knowledge proofs, you can instead just like receive a snapshot and say, here's your Bitcoin balance. I'm giving you mathematical certainty that this is actually the result, but you don't actually have to run and perform all of that work. So that was a little bit of like a long tangent, but hopefully that kind of elucidates some of the logic here.
I mean, initially, was privacy the use case, or did immediately people figure out that you could use this technology for scaling? And maybe we can go into a little bit, we'll get deeper into that conversation, I think scaling is going to be the focus of the chat. But was privacy like a main priority for anyone initially, as far as you can tell?
Yeah, I mean, I think privacy was like the original impetus, and so I got off track there a little bit. But yeah, in 2016, they invented Zcash, which was this way to do these perfect privacy transactions using zero knowledge proofs. But the way that zero knowledge proofs, there are things called SNARKs and STARKs. The SNARKs stand for succinct, non-interactive arguments of knowledge, which is kind of a clunky way of just saying that you can perform some sort of validation, some sort of computation, and you can compress it into a single proof. And when you compress it into that singular proof, yes, like you don't have to see all the computation and all the data that went into it. So that gives you the privacy. But as a byproduct of that, you're also compressing it into this succinct proof. There's really two aspects of these proofs: the privacy aspect, but then also the succinct nature of the proof, which gives you these scalability benefits that allow you to do something up here off chain that's very complex and requires a lot of compute, and then compression into it. When people are talking about zero knowledge proofs nowadays, I think the ideological people are more interested in the privacy aspect, but the mass market, I think, is more interested in its applications as a scaling technique, the succinct nature.
Yeah, that makes sense. I mean, like, just like intuitively, it seems like that's like the core problem that people want to solve with Bitcoin. Okay, so first 2013 came onto the scene. People were playing around with this for privacy, realized that by compressing this data into effectively like a kind of hash, you could also create a scaling solution because the data was succinct and therefore could fit theoretically on the blockchain. But it wasn't used on Bitcoin for a very, very long time. I think Ethereum was playing around with zero knowledge proofs. Why weren't people doing anything with this? I mean, now we're talking about 12 years later when people are actually thinking this could become possible. Why wasn't it possible on Bitcoin for so long? Like, let's kind of go through a little bit of, the sort of the past 10 years of how this technology has evolved.
Sure. So you actually mentioned something that, like, I'll mention, and I discussed this on like a podcast episode that we have coming out with like our founding cryptographer, Liam, who's like one of the world-class cryptographers on like ZK and Bitcoin. And I was like, what is the difference between like a zero knowledge proof and a hash? And like a lot of people do understand this concept of a hash. Like you can take all this data, you compress it into this succinct proof. But like a hash, it doesn't actually tell you anything about like that bigger data or that bigger computation. It's just a hash, just a piece of data. A zero knowledge proof is that same type of compression, but you can prove certain attributes about that hash. You can prove that all of the activity that you did to compress it has like certain attributes, like it was a valid payment, or like the order of the transactions happened. Like you can prove certain characteristics about it. So small side note there about like the difference between a hash and a zero knowledge proof. But going back to like what took zero knowledge proof so long. So yeah, 2016 they had Zcash. And then I think probably starting in like 2019, I think there was a guy actually by the name of like Barry Whitehat, that's his pseudonym, who invented this idea of like a rollup. And that is a similar concept to a sidechain where you have a separate blockchain that you can use as like a way to scale or add some sort of programmability or different features to like the base layer blockchain. And then people said, hey, like we can take this idea of like a rollup and then we can combine it with these ideas of like zero knowledge proofs. And then we can, essentially create like a trustless two-way peg, which basically means that, in Ethereum's case, you could take Ethereum, the asset on the layer one, you can bridge it without any added trust into this layer two, this thing called a rollup, which is kind of like a quasi sidechain.
Is a rollup basically just a sidechain with like a more trust minimized peg? Like, what is the difference technically between a rollup and a sidechain?
Well, there's two things. So a rollup without any of the ZK component is just a sidechain, but it posts its transaction data inside of the parent blockchain. And that gives it a couple of benefits. It kind of just like adds security. It allows it to inherit what's called like the double spend protection of the parent blockchain. A sidechain is just a completely separate blockchain. Like it has its own consensus, its own nodes, but a rollup, because you're posting some of this data, this transaction data into the parent blockchain, you're inheriting some of the security and the attributes. But a rollup itself doesn't necessarily get you the trustless two-way peg, which is the key component. It's like you want to take the base asset, or in our case, eventually BTC the asset, bridge it into the rollup, and then bridge it back. It's this added ZK component of the ZK rollup, which kind of gives you that trustless two-way peg.
And is there like special fancy math involved? I mean, so there obviously is special fancy math involved for the ZKP that enables these special characteristics that you mentioned. Is there like any universe where like a layman could get a TLDR on like what that math is and like why it has these fancy characteristics that just like a plain old hash wouldn't have? Like, what is it really doing under the hood?
Some of the true cryptographers listening to this will probably shake their head, but but the analogy that I've told that makes sense to me is like, if we walk through a basic example where like you, Isabel, say you're colorblind or something, and you're holding like two apples, a red one and a green one. There's just something that you cannot grok. Like you just do not have the physical limitation to see that these are two different colors. So if we set up this scenario where I said, like, I'm going to prove to you with mathematical certainty that these are different colors. And you're like, that's impossible. Like, I'm colorblind. You literally can never prove it to me. And so we set up this kind of like math game where I say, all right, put the apples like behind your back, hold them out. And then I'll tell you, if you essentially they change hands, and you do that. I say, well, now the red one's in your left hand or whatever. And then you do it again. And then I say, it's still in your left hand. Then you do it again. And then we do that about like 100 million more times. And eventually you get to this, like what's called like probabilistic certainty, or like you get to this mathematical certainty that, wow, like this person has correctly and accurately guessed this result 100 million times. I have pretty good certainty that these are, in fact, actually different color apples. Hopefully that's like a layman explanation. The way that zero knowledge proofs do this, it's mostly just multiplication. That's about the best that I can get you. We use
like a lot of multiplication, like a ton of it.
Yes. And that was part of the reason why zero knowledge proofs were actually so impractical, is that the process for creating the proof, or like kind of running that game, was like so complex that it was infeasible to kind of like create the zero knowledge proof. And now over the past 5 years, because of this like use case in blockchains to scale them, it's just, people have invested huge, insane amounts of money. And like, if you've heard of like Moore's law, where it's like the semiconductors are just like exponentially increasing, like the same thing is happening with zero knowledge proofs, where like the cost to create these zero knowledge proofs and kind of like run that mathematical game that I'm talking about is just like improving exponentially. So people are able to start processing these like much more efficiently.
So in 2013, when this idea of using this tech for scaling kind of first came onto the scene, it was basically just totally impractical / impossible to do it in any kind of blockchain environment. And then people put a ton of money and put a ton of effort into trying to effectively optimize that game. Ethereum, would you say that it's fair to say that that was mostly happening in the ecosystem of Ethereum? Like, I was not at all familiar with any of these games that were going on as sort of like a Bitcoiner who knew nothing about Ethereum 3 years ago. Is that fair? Would you say that Ethereum did a lot of like of the groundwork, or people building ZKPs style bridges on Ethereum was useful in that optimization?
100%. We owe huge amounts of credit, and we should have a ton of gratitude for the Ethereum community, especially coming from Bitcoin. Like, a lot of people, they just like hear Ethereum and they're like, oh my gosh, no. And they like, say something like bad and evil about them, or essentially it's like, dude, no, like a lot of these people are extremely world-class, brilliant, pushing the frontier of this technology forward and like investing serious amounts of money in it. Huge praise to the Ethereum community for driving a lot of this stuff forward.
How much success has there been in terms of making ZKP style bridges on Ethereum successful? Like, how has that whole experiment gone? And then we'll kind of move to Bitcoin.
I think Ethereum has proven that they are like competent of actually like pushing some of this stuff forward, but it's definitely not there yet. Like, there is a website called L2beat.com where you can see like all of these ZK rollups or different rollups that we're talking about. And it kind of like grades them, where it's like, hey, like you're saying that you're trustless and you're saying that you use these zero knowledge proofs, but like, do you actually? And I think we're now in the phase where the training wheels, so to speak, are starting to be taken off. And these proof systems, or these zero knowledge proofs, are actually starting to like kind of stand on their own merit, like, going beyond the research and into the actual practical implementation. I think there may be one or two that have kind of taken off the training wheels. Don't quote me on that, or they're kind of on the precipice. So is the jury still out? For sure. But is it looking pretty good from what I can tell? Yes.
And you think the core value of this is just literally trustlessness, right? It's just specifically, how do we get as trustless a bridge as humanly possible? Do you think that there becomes like a point where trade-offs around ZKPs and trustlessness become kind of important to think about? It's like, okay, like I'm willing to go down like a little bit this much trustlessness to have like a little bit of this much more convenience. What are your thoughts on that?
In the ideal world, yeah, like we have this perfectly trustless peg, and we get like insane amounts of throughput. And in Bitcoin, we have like unbounded levels of expressivity. Like, hopefully we have it all. But yeah, there will be certain situations where users will ultimately have the choice, where it's saying, look, here is the kind of like the purest, like the trustless, like as trust minimized as you possibly get. But if you want to take other trade-offs, which you can opt into and you can choose, then maybe you can get higher throughput or something like that. Like, I want to be clear, like they're pretty freaking amazing magical technology, but they're not alone silver bullets. And maybe that's kind of what you're indicating here, is that at certain ends of the spectrum, like there still will be kind of trade-offs that people can take with trust versus performance or features.
Where did Ethereum get stuck, right? Like if you're like, we're not there yet, just on Ethereum, just on the Ethereum history side, because that was sort of, I think, there was sort of a big boom around this and a lot of investment, as you mentioned, going into this a few years ago and continues to be the case. Where did Ethereum get stuck in this effort of creating this sort of perfect zero knowledge proof ZKP rollup style scaling solution?
Where did they get stuck? Well, I guess like spawning off of Bitcoin, like they originally looked into state channels, which is kind of like Lightning Network. And then, yeah, Lightning Network uses payment channels. You use route payments. State channels are kind of like smart contracts, but with payment channels. They kind of abandoned that. They went to this idea called like plasma. They looked into this thing called like sharding. Anyways, all those ideas kind of like flopped. And eventually they're like, hey, like rollups is the way. Is that kind of what you were asking?
Yeah. But I mean, you said that they haven't been like 100% fully successful in creating this truly trustless, or I don't even know if truly trustless is the appropriate word there. Where does Ethereum still have room to go? What did you mean when you say we're still not there yet, or Ethereum's still not there yet? What does there mean?
I'm saying, so like, like you have the Ethereum base layer 1, and then you have a layer 2. We'll just use maybe like ZK Sync or whatever, which is like one of the original pioneers of ZK rollup technology. And like you can go on to ZK Sync, which is a layer 2 rollup on top of Bitcoin, and you can process transactions, you can do smart contracts, all of that stuff. But I think technically, are they processing those transactions on the layer 2? Are they creating a zero knowledge proof and then posting that onto the Ethereum layer 1 and using that exact functionality as a way to secure the Ethereum peg that exists on ZK Sync layer 2? I'm pretty sure no. Like I think they are at the point where they are like creating a zero knowledge proof of all the stuff that's happening on the layer 2. I think they actually are posting it onto Ethereum, but like it's not yet securing the peg. Like I think maybe they're still using like a federation for now. And by removing the training wheels, I'm kind of saying like, hey, like you're transitioning from like all of the infrastructure is in there, but we haven't yet enabled it, to like now actually enabling it. Sorry, the ZK Sync team, if I'm like misrepresenting, I'm just using that as an example. The whole point is like, it appears that the infrastructure is like there and ready in place. It's just a matter of someone saying, okay, we're going to make that official switch.
Okay. So then so now we have sort of like a little bit of a sense of where Ethereum is on this whole process. What was the big unlock for people actually starting to take seriously building a zero knowledge proof style bridge, roll up, et cetera, on Bitcoin?
I think the earliest and the first was a guy named Tradeoffs, who's one of the engineers on our team now, kind of wrote this article about how you could use covenants, a potential soft fork in Bitcoin, to like create a roll up. It was just kind of like a little thought piece. Like nobody really even saw it. I think it was John Light, who's our technical product manager on Alpen. He had written this research paper that I think a lot of people saw. It's like bitcoinrollups.org or .io, I can't remember. That was from a grant from the Starkware guys and the Human Rights Foundation, people like Alex Gladstein. And John, who was an advocate for sidechains and even drive chains, said, hey, like I think ZK rollups are a superior version of those kind of like old tech. And he wanted to see if you could actually bring them to Bitcoin. So he went through this whole process of researching and saying like, here's this paper. Here's how you could actually build ZK rollups on top of Bitcoin. The caveat was that it required 2 soft forks. One is covenants, in a specific form of covenants called recursive covenants. And then it also needed this thing called a zero knowledge proof verifier. So it was kind of like this thing that nerd sniped a lot of us in Bitcoin. And we're like, oh my gosh, it's so cool. Like we could create zero knowledge rollups. This is like holy grail. Then I was like, it's going to require a soft fork. Like anybody in Bitcoin knows how difficult, if not maybe even impossible, that's going to be to do. So it was just kind of like, it was put off to the side. And then it was Casey who came up with ordinals and said, we can essentially post arbitrary data inside the Bitcoin blockchain. And that kicked off a whole bunch of kind of new experiments. The next iteration was this guy named Linus said, hey, I think that we can actually hack in a ZK verifier into Bitcoin using kind of some of the concepts of ordinals. And then people like John Light said, well, hold on. Like if we can hack in a ZK verifier, then we can actually bring back this idea of bringing ZK rollups on top of Bitcoin. And then that's kind of like kickstarted now this whole movement in Bitcoin. So maybe I'm getting ahead of myself here, but you can redirect.
No, I think that was great. Let's break it up piece by piece. Okay. So Casey figures out basically the sort of like idea of using Bitcoin as effectively like a data availability storage center, right, essentially using Bitcoin for storing data. And then Linus, this is, I think, like a key part of the history that people want to like better understand. Linus wrote this paper, BitVM, maybe some of folks have heard about it. And that essentially used some of the concepts or adapted some of the concepts of using Bitcoin for data to like chunk together some sort of ZK verifier type thing. How would you TLDR the original BitVM 1 concept for folks who are just like, what does that mean? How does that actually work? How did he do that? How would you TLDR what BitVM did and how Robin Linus sort of created this clunky ZK verifier type situation?
Okay, if I tried to explain it in like very simple layman's terms, I would say that Bitcoin script, which is the language that Bitcoin uses, is like very, very simple. You can't really program too much with it. And that's like the main sticking point of why Bitcoin intentionally does not have much like programmability or what people call expressivity. What Robin kind of figured out you could do is like, we can run all of this computation off chain. Like Bitcoin has no idea, your nodes have like no idea what's going on. We can run all this computation and then we can set up this game where if the computation isn't ran as we all expected or we agreed on off chain, then somebody can post just a tiny chunk of data on chain into the Bitcoin layer 1. And the Bitcoin layer 1 can essentially arbitrate that and say, hey, great, you have submitted evidence to me that this was not run properly. So therefore, I'm going to, slash or penalize the person. So it's more of a game theoretic setup where we're using Bitcoin as the arbitration layer to make sure that people run things as we intended. And in this case, you are saying that I want you to verify this thing called a zero knowledge proof. And so all that's kind of being done a little bit off chain. And then any evidence of it being run incorrectly, again, it can be arbitrated by Bitcoin on layer 1. That was kind of like BitVM 1. BitVM 2 has changed a little bit, but that's the core concept.
So basically you have folks, effectively operators, validators, I feel like people call them different things, verifying ZKPs offline, right? Off Bitcoin essentially. And then you create like a situation where like people can check each other's work essentially. And if somebody decides that somebody suspects that somebody is, not being honest or lying or just wrong, then this whole game starts where you can like literally like prove the math on chain, but you have to do it in chunks. And that's where ordinals and inscriptions becomes important. It's like you have to like store the data of your chunks essentially of how you're proving all of this math in multiple transactions. Is that correct-ish?
Yeah, function. I mean, so now kind of what you're talking about is this this kind of transition that we went from like BitVM 1 to kind of this like BitVM 2 paradigm, where we have these things called like chunks. And so what's happening now in BitVM 2 is like instead of doing all of this kind of like off chain and then posting like a single small piece of data on chain, we're actually like kind of doing this ZK verification on Bitcoin layer 1. Like I previously described, like the way to verify a zero knowledge proof is doing like a lot of multiplications. And so if we could just do multiplications on Bitcoin, like we could hack in a ZK verifier. But again, since we can't actually do that, Bitcoin can only do addition. It can't do multiplication. What we're doing is we're writing what's called like a Bitcoin script. And we're basically doing like add, like a ton of different like opcodes, like huge, like an absurd amount of them. And you're kind of like emulating or hacking in multiplication, which allows you to then emulate this kind of ZK verification. So we're almost like preparing a script like that to verify a zero knowledge proof in Bitcoin script, like kind of fake multiplication. And then again, like if someone like tries to perform that computation wrong, then as you were saying, like somebody could go through this script and say, right here, this chunk, like there were 1,000 chunks in chunk number 27. Like this is where you lied and you were deceptive. Somebody can spend that on Bitcoin and arbitrate that the computation was done incorrectly.
And this is essentially what people mean when they say an optimistic rollup, right? An optimistic rollup is such that actually it's not, the state is not being verified on Bitcoin unless there's a challenge, unless there's like a suspiciousness of wrongdoing, at which point people do have to prove their math and they can take, as many transactions are needed to prove their math. And I guess part of the game is optimizing how many transactions are required to prove your math in a challenge situation. Is that accurate?
Yeah, no, you're exactly right on the optimistic setup that we're kind of like optimistically assuming someone is honest, or that this kind of like this peg in the ZK verification is happening honestly. And then if someone is lying, then anyone else can be like, hey, no, I can see that you're lying, so I'm going to call fraud on you. So that's kind of the optimistic setup.
And the point of the optimistic setup is that you don't have to do all of this math to prove your ZKP is accurate, right? You don't have to do all of this math in one transaction. You can just sort of play around optimistically. Transactions can happen assuming that the math is correct. If somebody challenges and says, no, I want you to do the math on chain, I want to see the math on chain, then that takes multiple chunks, commits, transactions to do, which is expensive and time consuming, and probably one of the criticisms of this game, right? Is that it takes a lot of transactions and money and time and, et cetera, to prove the math is correct in the event of a challenge. First, let me stop there. Is that accurate so far? And then we'll talk about, kind of how people are managing this criticism.
Yeah, I think that's accurate.
Okay. So then I would imagine, and I think that this is sort of part of the game of optimizing for ZKP rollups, and sort of what people are working on is, how do you get in a challenge situation? How do you optimize this math so it takes the least amount of time and the least amount of money to prove your innocence or whatever? Is that accurate?
Yeah. So I think what you're kind of implying here is that like we are fairly confident now, and we can kind of see that like we can have a working implementation of BitVM. TLDR will be able to bridge Bitcoin into these other ecosystems and bridge it back with like the least amount of trust possible. Something called like a one of n trust assumption, where as long as one person out of n number of people, like any arbitrary number of people, is honest, then the peg is secure. And that's like pretty badass. But in order to get that trust assumption, you're saying it's like, well, what's this going to cost? Like if I have to defend the peg, is this going to cost me, like $1 million to defend $1,000? That's where a lot of the kind of bleeding edge of this BitVM research is like, well, how can we optimize all these different components to make this actually economically practical? So in this BitVM setup, like let's just make it easy and say that we have like 10 operators. So you'll take Bitcoin from like the layer 1, you'll bridge it into the layer 2. Technically, there's kind of like 10 operators, almost like a multi-sig, that are like guarding those funds. But as long as one of them is honest, then you'll be able to facilitate the peg back. But each one of those operators, like they have to put up Bitcoin as stake, as collateral. If they're malicious or they're not honest, then their stake will be slashed. And so how can we get BitVM in a way where, again, like they don't have to put up an obscene amount of Bitcoin collateral to secure the peg? I'm not sure how deep you want to get into the technical weeds, but that's kind of the premise. And like a lot of the stuff that's been going on behind the scenes is optimizing that.
How successful has that optimization process been? Like, how expensive? I know that's like an impossible question. There's so many inputs in the question. How expensive is it to, execute a challenge, basically? And maybe, part of the answer there is, well, we assume that challenges will happen so rarely. I've heard people give that argument. Challenges will happen so rarely that it, even if it's astronomically expensive, it doesn't really matter, because like the game theory is such that this will happen only once in a blue moon. What do you think is up with that? I mean, how do you think people are managing this issue? Like, how are you guys approaching this issue of dealing with the cost of a challenge and the time and the, sort of clunkiness involved with a challenge?
Okay, so there's multiple things. So we kind of mentioned that like in Bitcoin script, like we're hacking in this like ZK verifier. So we're kind of like emulating all of the multiplication. So the more efficient that we can do multiplication, the kind of smaller the script is, which means the cheaper it's going to be to defend the peg if there's this instance of maliciousness. And so, most of the work has been like people coming up with really creative ways to do like multiplication basically with like addition. And so like that has been successful. I think we've had like at least an order of magnitude, like 10x, if not more, like improvement in that. And so ultimately, like if we get to this scenario where somebody has to like defend the peg, I think it's like less than one full Bitcoin block in order to do so. So if you say that there's
so you could defend the peg in one transaction.
Yes, but there's,
if you could do a 4-megger.
Well, exactly. So that gets into the whole whatever it's called, the
standard transaction. Yeah.
Yes. Where like, typically, you only propagate, 400 kilobytes or whatever it is, the size of transaction, even though a Bitcoin block would fit 4 megabytes. But so you'd have to go directly to a miner like Marathon and use their thing called Slipstream. Anyways, like that's probably a little bit more of a nuanced thing, but yes, like it's looking like you'll be able to defend a peg if you just pay like an entire block.
Okay, so then in standard transaction land, which is I guess what we assume people are actually going to use right now, the cutting edge, how many transactions would it take to defend a challenge?
This is a difficult question because like a lot of this is like implementation details. Like teams can like tweak the parameters and say okay, like I would rather have like everything fit inside a standard transaction. And because of that, like you're going to have more transactions. Or some teams are like, we don't care if it's a non-standard transaction. So I won't be able to give you like an exact answer because it's going to be like based off of a team by team implementation. And I think several of the teams, including us, are kind of like deciding which way is the best to do that.
What are the trade-offs that you're sort of considering in that equation?
It's mainly just like, are people going to want to be able to have to submit standard transactions?
Oh, that in and of itself is something you guys are thinking about. Is like, oh, maybe we don't even need that. Maybe we could let people, do it, submit transactions directly to miners and like bypass mempool standardness.
100%. Yeah, because that's kind of the feedback that we're getting. People are like, yeah, like if you're defending a peg that has like 1,000 BTC or 10,000 or whatever BTC, like, do we really care about it being a standardness transaction? And the feedback we kind of got is like, okay, that's really not going to be an issue.
Not really. Yeah, yeah. Well, so that is certainly the case with really, really, really big transactions. Do you think that this is a technology that will mostly be used for really, really big kind of institutional transactions? Like, will little guys use this, or will be something else that little guys use on top of this? Like, how does that all work?
Yeah, it's a good question. No, I mean, most normies like will not use the BitVM2 style bridge. Like these bridges are purely meant to like secure the peg and make sure that like 1 Bitcoin on the rollup is worth 1 Bitcoin on the layer 1. Most users, they'll either just like onboard directly from the layer 2, or they can use these things called like atomic swaps, something like bolts, where you'll be able to much more easily and instantly just kind of swap, Bitcoin from the layer 1 to the layer 2, and vice versa. Even if there was risk of like the BitVM bridge going down and there was some challenge and it's like taking the 2 weeks to execute it and all this stuff that we're kind of talking about, normies are not going to go through that. Like all that's going to be handled by specialized actors that are saying, look, I understand the tech, I trust the process, I'll recover these funds on the back end.
Okay, so there'll be some sort of like custodial version of this essentially for normies, but then like how does like will normies have to trust somebody to have the little transactions happen, or they'll just be operating on the roll-up level, I guess, maybe?
No. There's no trust here. You can use something called like atomic swaps. So you can take like Bitcoin from like the layer 1 into like the Bitcoin layer 2, and it just atomically like swaps it.
Oh, I see.
There's a way that happens. But how do you get that Bitcoin on the layer 2 in the first place? And the way that you get it there in the first place is like going through the BitVM2 bridge. So there's a difference between like how the layer 2 Bitcoin comes into existence in the first place, and once it's already there, how you swap between these two. The people that use the BitVM2 bridge are like the actors that are essentially the kind of genesis of Bitcoin into the ecosystem. And then they will ultimately be the last people, if necessary, to leave the ecosystem, if that makes sense.
Well, so it's interesting because one of the other criticisms that I've heard of this that I wanted to ask you about was, sort of like liquidity issues. Like this would only make sense for like really like big institutional transactions. But this is sort of the solution to that problem, is that you use atomic swaps between the rollup and layer 1 for retail, essentially. And then the bridge only is necessary to defend the peg.
Yeah. I mean, I think for most normal people, that's all you really need to know, is like it's just going to be a seamless user experience to get in and out of there. There is that issue that you kind of alluded to where like technically on the back end, there's this liquidity fronting concept where, again, if we went through that example where there's like 10 operators who are managing the peg, and some big actor says, hey, I don't want to use atomic swaps. Like I want to bridge out a shit ton of BTC. Maybe they request 1,000 Bitcoin to come out of the layer 2. They're essentially going up to one of the operators and saying, look, front me this money. Like this is an honest withdrawal. Like I truly actually have 1,000 BTC on the layer 2. Front me this withdrawal. And one of the operators will front them that money. And then the operator will actually go through the BitVM process to get the reimbursement from the bridge. So there is like a little bit of clunkiness there that I think people have brought that up as like a valid concern. Like this was first kind of brought to light by Eric and Udi and Tyler, like the Taproot Wizard guys. There's a couple ways to get around this though, like in what's called like the happy path, meaning that we were kind of optimistic, but there actually was in fact like nobody's challenging, there's no fraud, no malicious activity. This is called the happy path, which we expect to happen most of the time. An operator can actually recycle withdrawals. So by this, I mean, if again, somebody is wanting to withdraw 1,000 BTC and the operator only has 10 Bitcoin, it's like, holy shit, like they're not gonna be able to process that. Well, they can essentially pay out 10 BTC and then immediately get reimbursed from it instantly, atomically, and then do it again and again and again and again and again. And so you can do that like 100 times. And so with only 10 BTC, you can process like 1,000 BTC withdrawal if you're in the happy path.
Is there like a certain like threshold of amounts of BTC where you imagine people will stop using atomic swaps and want to go through this bridge process? Is it just like a function of how expensive it is to go through the bridge process?
It's hard to say because like the atomic swaps are based off of like market makers. Like somebody is going and creating a market there where like if you, Isabel, you want to go over the atomic swap bridge, like I'm just an actor where I want to make money. And so I have Bitcoin on the layer 2. And so I will like pay you out that money, and then I will, collect your Bitcoin from layer 1. Like I'm essentially just buying and selling. Like I'm a market maker. And so it's hard to say what the threshold is going to be because it's going to be dependent on like how much market makers are willing to kind of like process those atomic swaps. Does that make sense?
Yeah, it does. So this actually brings me to my next question, or like a whole nother like series of questions that I wanted to ask you, which was how do operators are taking a fee for this service of basically like providing these like institutional grade bridging transactions with actual BitVM ZKP bridge? Is
Yeah.
that yeah.
So the operators will say, well, sure, like I will front you the money because I can clearly see that this is an honest transaction. So I'm willing to front you the money, but I'm going to charge you a fee for that. So this kind of gets into the economic considerations of the bridge. Well, it's like if someone wants to be an operator, they're going to have to stake a certain amount of Bitcoin. And then it's like, well, okay, so how many withdrawals and deposits are happening? What are the fees that the operators are going to charge on that? Does the yield that they would earn for facilitating these BitVM transactions, does that justify the amount of stake that they've put up? Like these are the kind of the next questions after the technical considerations that like we're kind of starting to get into right now. It's like, well, how much do operators actually want to earn on this? You can look at something like WBTC or wrap Bitcoin flows, and like you can kind of run the math and be like, okay, we expect to have this many flows. Like this means operators will earn this much in yield.
But is that something that the protocol would decide, or that would be like a free market yield that maybe could fluctuate depending on the price of Bitcoin or other factors, right? I mean, would that those pricing considerations are something that would be flexible, I imagine, or like market dependent? No.
Yeah, I mean, my understanding is that the operators can choose whatever fee they want to charge. I suppose like we could hard code it into the implementation and say like you have to charge this fee, but no, I mean I'm pretty sure the bridge operators will.
So fees will vary. Fees, we'll see what happens. It's like it'll be like free market fees, and we'll see. I was going to say like how would the fees in this situation potentially compare to something like fees for Lightning operators, but maybe that's also sort of like an impossible question at this point.
Yeah, I think it's too difficult to tell at this point. I mean, you can kind of like again, you can back into it and say like, well, what do operators want to make? Like they probably want to earn like, I don't know, call it 15% yield on their Bitcoin. Like that's pretty healthy. Like I'd be happy if I could earn 15% yield on my
annually.
Bitcoin. Yes, annually, exactly. So it's like, I don't know, if I put up 50 Bitcoin as a stake and I want to charge, I don't know, like 5 basis points for every withdrawal and deposit, like how many withdrawals and deposits and what size are going to happen. So there's a little bit of a math formula there, if you can tell. Like some of it's TBD, but like we can kind of like high level guesstimate what some of this stuff will be based off of flows we're seeing into like Ethereum from wrap BTC.
I think that that's probably more than like your average Lightning node provider, or like Lightning liquidity provider is getting at the moment, but not totally sure. Again, I think that that's variable as well. Interesting kind of to compare this with Lightning. Obviously, I think the biggest difference, there's sort of technical differences, all sorts of difference, but the biggest difference that people talk about is just what it enables. Is your sort of point of view that this will make Lightning irrelevant, or will Lightning still be important for payments? What's sort of your point of view there?
I mean, I think there are different use cases. Like I think definitively what rollups, which is what we're using the BitVM style peg to create, can add is expressivity to Bitcoin and like trust minimized expressivity to Bitcoin. So we can have an EVM layer, we can have solidity contracts for what Ethereum uses. Moving forward, like, maybe you move into phase 2 and maybe you can add an SVM into it, which is Solana's. Maybe you could add Cairo, which is Starkware's. Maybe you could add Clarity, which is Stacks' programming language. Maybe you could even just do everything in like Rust, which is, there's like 30,000 Solidity developers. There's like, I think like 3 million like Rust developers. Like you can start adding arbitrary execution environments and programmability to Bitcoin with like a very trust minimized peg. That is super badass. Now, to answer your question about like, is Lightning still relevant? Well, Lightning theoretically can achieve much higher scale of payments than these rollups. But Lightning comes with a bevy of issues. Like this has been well documented, but there's like the inbound liquidity issue. There's just kind of the clunkiness of the UX. Like you can get rid of all of that with a roll up, and it's much more similar to the payment experience that you'd be accustomed to, like even if you were just on Venmo or PayPal, where it's like, hey, here's my address, just send me money. Like you don't have to worry about getting inbound liquidity. You could be in this world where you don't have to pull out your ledger and like sign for your thing. Like you could just use Face ID on your Apple iPhone. Like when you add this programmability to payments, you give world-class user experience, better than what we could have in Venmo. Like you could take an entity, a very wealthy entity. I'm just making up an example, like Jack Dorsey, and he's like, I want to onboard all these people into like Africa. He's like, I'm going to cover their transaction fees, and like he can pay for the transaction fees for them to onboard and make payments for a certain amount of money or something. There's just like, the user experience that you can create is just far superior.
And you can do this all non-custodially. I mean, it sounds like this is sort of a key distinguishing factor as well, is like most people are realistically using Lightning in a custodial way because of all these sort of UX issues that you're talking about. With zero knowledge proofs or with sort of the ZKP BitVM style roll up, what would the user experience actually look like? Like, would you have like the ZKP kind of style address and then the on-chain address? I mean, how does that all look?
So now this topic that we're getting into is something called like account abstraction. But with account abstraction, it's a way to kind of like program like a wallet. So like in current Ethereum setup, like it's difficult. You can't really like program the wallet. Like you have seed phrases, and you need to like sign for all the transactions. But with this concept called like account abstraction, which is a functionality that you can create with these kind of fully expressive environments, like I could, I could just like go to my phone right here, and I'd just be like, all right, Isabel, like give me your username, give me a QR code, like whatever you want, and then I just send it. Like that's it. And there's no trusted intermediary anywhere in there. Like technically, these phones have like a ledger. It's like a hardware. It's like a secured way to store your private keys. Like that exists like in this phone. Technically, we don't need ledgers. Like we could just like use all of this ledger treasure that exists in the phone. And if you have something like account abstraction, like you can store your private keys like in your phone. And again, you can use Face ID or something, or you could do like two-factor authentication. Like you could use a social login like Google. Like you can build any of this.
Is that something that you can uniquely do with the ZKP BitVM architecture, though? Or could you theoretically also have that kind layer of abstraction with Lightning, in theory?
I don't think that you could have it. I'm pretty positive you cannot have it with Lightning. Because you need the ability to add like expressivity, or again, like programmability, like to literally like write code and says like, if this happens, then this occurs. Lightning Network, it doesn't have programmability to it. Anything that people like hack in that kind of functionality where it's like, no, like I'm sending this Lightning transaction and I have two-factor authentication, like it's sending me an email. Like there is some sort of like custodial element that is going on there. Yeah.
So basically, in order to have this sort of particular user experience that you're explaining, like you actually do need the programmability piece of things. Could you still do the atomic swaps between Bitcoin layer 2 and the rollup though in that scenario?
Yeah.
Oh, excuse me. Okay.
100%. I mean,
Okay.
rollups have like their potential issues, but the thing that they do not have an issue with is like creating programmability and expressivity, and that is huge.
Okay. So that's pretty key also. So you have programmability, which I think, I mean, for me, I just think of like DeFi, lending. I think of all of those use cases. I wasn't even thinking about I've never even actually even thought about the user experience benefits of having programmability, but that actually seems pretty huge. Like that's like a big one for people to be thinking about. It sort of is, I mean, now in retrospect, it's like, that's the big distinction between EVM, Ethereum applications and Bitcoin, right? Is this sort of user experience. I think that might be like sort of the biggest challenge that Bitcoin is facing. And that potentially gets solved in a relatively trustless or trust minimized way using this sort of BitVM ZKP style bridge. Is that fair to say?
Yeah, exactly. And even I think you hit the nail on the head. It's like so many Bitcoiners that I talk to that are kind of like, of the maxi type, they don't even want to acknowledge some of these other use cases. I'm like, well, no. Like you literally can't achieve like this level of UX unless you have this programmability. So this concept of like account abstraction, which is what I've been describing this whole time. Like even the most ardent of Bitcoiner isn't going to be like, no, I don't want better user experience,
So true. I that didn't even honestly that hasn't didn't even occur to me until this conversation, which is like kind of blowing my mind actually. I was just like, "Oh, I'm sure they actually want lending and they don't really understand that they want lending, but like actually they do." The UX part didn't even occur to me. It's
Yeah,
pretty interesting.
it's insanely powerful.
So it's funny is now we're sort of getting into like another line of questioning that I wanted to get into potentially, which was sort of and similar to this question, is this Bitcoin season 1 or is this Bitcoin season 2? Where does this fall? Which is this is also you guys made an interesting decision that was different than some of the other companies that you are potentially competing against, which is that you decided not to launch a token, or you're not going to have a token as part of the incentive architecture of this validator network. Is that accurate?
Yeah, I mean, you don't need a token whatsoever to use the rollup. Like the native currency will be Bitcoin. And yeah, I mean, we don't have plans right now for a token on the roadmap. We are taking like a neutral approach to a token because like we're not going to let the kind of like dogmatism dictate the position. But I can tell you honestly, like a token doesn't get mentioned inside the company. I think that we're well aware that tokens, frankly, are just like horrendous. They're just terrible for incentives. Yeah, it's actually something I get like really bothered by. We are all humans, and like no matter how like ideologically motivated that you say you are, if you get a random token and it's worth like $10 billion and you have shares of that, you're like, oh, like maybe I just like don't want to keep building this product. And I think for us, like we still feel strongly that like the mission is not over. Like we are wanting to bring like expressivity and scale to Bitcoin, and to like risk tarnishing that with like a token that distorts incentives just to like pull an exit. It's just like, dude, no.
People make the argument, and I hear this all the time, and I always am like a little like on the fence, like not sure like how to manage this criticism or like what to think of this criticism. People will say, but you actually do need a token to incentivize the validators for the system to work. Why do they say that if it's not true? What's their point of view? Where are they coming from on that? And maybe you could talk about like sort of the hole in the argument, but like what is that argument?
Okay, so there's a couple of things here. Like in theory, like there are additional services that you need to like run to operate a blockchain, like maybe an Oracle or something. And so it's like, what motive and what incentive are they going to have to like operate these services? And you could say that you take something like eigenlayer, which is a concept in Ethereum, and you say, well, hey, they can take their existing stake and they can stake it into this kind of separate network that maybe does like Oracle services or something, or maybe it does cross-chain bridges. Like it performs some sort of additional services in excess of what the Ethereum base layer can do. It's like, well, great. Like we can just use the Ethereum asset, or in our case, I'll convert it to Bitcoin. I'll say that like we can stake Bitcoin and it can perform some sort of services that the blockchain may need, and then they earn fees paid in Bitcoin. And if they're Bitcoin, and if they're lying, these validators are lying and not operating properly, then you can slash them. And so that's a scenario where it's like you need no other token whatsoever, right? Are you kind of following so far?
Yeah, I mean, I'm still kind of curious. Like, is there any reason why having the sort of token, using a token in lieu of having to put up Bitcoin for this? I imagine that's where you're going, is people will put up Bitcoin for the staking.
Yes.
Is there any reason why having a token that's not Bitcoin be used first is useful in that scenario? Which is, I think, the argument that folks are making. But I'm very interested in the argument for why that's not true. But I'd be curious.
The justification here is, again, we have this like staking setup where it's like these services that people want to operate. We don't want to introduce a new token, so they're going to stake Bitcoin. Great. That's their incentive. They're going to get slashed if they are malicious or whatever. But there are these things called objective faults and subjective faults. So an objective fault is something that somebody was malicious, they lied, they didn't operate, and you can see that on the blockchain. You can say objectively right here, you lied or you made a mistake. So we're going to slash you. Great, done. There are some other types of functionality where it's subjective, where like you can't objectively prove it on the blockchain that like that somebody was actually malicious. Like we as an outsider can clearly see that like no, like they lied, And so it's more of this like subjective thing. And so in order to slash someone in that scenario, is you actually have to like literally fork the token and you slash them and you remove like Isabel's stake. I'm like, I can clearly see that Isabel lied, so I'm going to essentially fork it, remove your tokens, and then we're going to resume. The problem is you can't fork Bitcoin, and so it's like all of these additional services that people want to run, these concepts, maybe something called like a data availability layer. Um, Again, maybe some sort of Oracle. Like if there's a random issue on like the layer 2 because like I don't know, somebody withheld some sort of data, like you're not going to go to all the Bitcoin L1 holders and be like, hey, you need to fork the entire chain because like this random issue that happened. So this is one justification that somebody could give as to like why an additional token is necessary. Another is that some people just say, hey, like in order for these things to be sustainable, you essentially need inflationary rewards. Like you need some sort of like token that we can basically print out of thin air so that we can pay them to actually secure these services. Because going back to that example, like if somebody's running an Oracle service and say it's just like it's not getting much usage, like they're not getting paid enough fees to like justify their costs, they're just going to stop running the service. And you're like, well, shit. Now I'm like without an Oracle or something like that. I'm not saying that either of these solutions are like these justifications are right or wrong or whatever, but like those are, I think, like the closest thing to reasonable arguments for why a token would be needed.
Would you say that there's like some level of trade-off here in terms of using Bitcoin instead of tokens, but the trade-off of just using Bitcoin and not introducing a new token is such that it's just worth it to just use Bitcoin and not have to deal with the kind of crummy incentives that come along with creating a token?
Yeah, I mean, tokens have just proven to be like so fucking brutal. I think where you can, like, you should absolutely 100% avoid a token. It just, yeah, I mean, it's just my rant that I gave before. It's like they're just like horrendous for incentives of like building sustainable products. And I even went so far as to like say this, that if we got into this thing in maybe like a year or two from now, and we just realized that whether it's like the infrastructure or the apps or whatever, like this stuff just, it literally cannot operate without a token. I personally would go and reassess my position, and I would at least consider and say like, all right, maybe we just like gave this thing a run, and maybe it's just like Bitcoin store value L1, like that's really all there is to it. Like if the only way to truly sustain is to like print ephemeral rewards out of thin air and subsidize the cost of that, and there's like no other alternative around that, that would make me reconsider some things.
Okay, so it's not like impossible. Did you guys get pushback from investors around this by any chance? That's something I hear a lot, is that investors in the space are like sort of kind of put a ton of pressure on projects to launch tokens. Did you guys experience that or not really?
No. Yeah, I mean, I think investors will take kind of like a pretty neutral position if you have the right ones. Like, how do I say this? The Alpen team in particular has like a lot of respect. And I think people see like their technical credibility. And so because of that, like we've kind of had our choice of whichever investors that we want. And so we don't feel the need to pull in investors that are expecting or pushing us to deploy some sort of token. Like if that was the case, then I think, and I can't speak for Sims, our CEO and other founders, they should be like, okay, like we don't need your money. Like, like we're trying to kind of do this our way. So when you have that kind of leverage and that authority and feel that you can actually build for the long term, then you're in a bit more of a position of power.
So it's interesting. I mean, one of the things that I also really love about your team is you're kind of you're Bitcoin maximalists, but you have sort of like a critique also of maxi culture in the sense, right? That you're like, okay, they're not thinking about UX, most of them, or like a good portion of the ones that are at least loud on Twitter, not thinking about sort of like use cases like lending or other DeFi use cases that might actually be legitimate, that, maybe we should be thinking about as Bitcoiners, as even Bitcoin maximalist users, or excuse me, Bitcoiners. What are your sort of thoughts about sort of the cultural shift that's happening there? Do you guys identify as a Bitcoin maximalist company? What are your thoughts?
I don't know if we identify as Bitcoin maximalists. I think that like we're very sympathetic to the maxi view. Like I've said this a bunch, that Bitcoiners honestly got a lot of things wrong, and I think there are many people who are kind of like maybe a little bit like entitled and arrogant in their views and really kind of lack like technical nuance. But what the Bitcoiners did absolutely get right is like what this revolution is all about, like what it's predicated on. It's this separation of money and state. It's about like sovereignty and agency, and this like almost like radical commitment to like money and decentralization. Like that resonates with me. But a little bit of the dogmatism around like the kind of tech, I think a lot of the Bitcoin maxi culture was like wildly wrong about the tech. And who knows, like maybe we will be as well. Maybe we're the guys that are so biased and we're coming in here and saying ZK rollups are the future and like look at our backgrounds and we have this great tech background. And maybe in a year or two, like we'll be completely proven wrong. But yeah, I mean, it's a very fine line with like the Bitcoin maximalism. In the absolute extreme, I don't consider myself a Bitcoin maximalist. Much more of a monetary maximalist. Like I don't really have interest in putting Uber on the blockchain or having like Dentacoin. Like I am here for separation of money and state. And I feel that ZK rollups using this BitVM2 paradigm is the best way for us to get there.
I love that. Okay. I think that might be a really perfect place for us to wrap up. And yeah, well said. I think that is maybe something that sort of Bitcoin season 2 is bringing to the forefront is like, okay, let's just have sort of more nuanced conversations about the tech. Think about what's possible on Bitcoin without necessarily getting into all of these sort of like other applications and games outside of money. But yeah, things like lending, things like DeFi, like those seem like reasonable things to explore on Bitcoin in a relatively trustless way. So, oh, actually, there was one more question that I did want to make sure that I ask you before we get off. So, how does you mentioned, obviously, Bitcoin script is limited, and sort of one of the challenges or one of the reasons why Robin had to create this sort of like big clunky BitVM, sort of paradigm in order to make this bridge work is Bitcoin scripting limitations. Are there any opcodes that you would like to see added to Bitcoin? Let's talk a little bit. Obviously, Opcat is getting a lot of attention. People are starting to talk about the possibility of a soft fork in Bitcoin and how we could get new opcodes. Are you pro Opcat? Is there a different opcode that you would like to see? How are you feeling about soft forks right now?
Oh man, well, I don't know how much longer you want this podcast to go on. I'm also not sure how many death threats I want to receive. So, but yeah, I mean, I would love to see covenants come into Bitcoin. I do get like a little bit just kind of like down that I'm like, we self-informed consensus on some of this. But yeah, I think that's like very valid that like everybody agrees that we kind of like want covenants or most like rational people agree that we want covenants, but like there's an agreement about like which covenant opcode. I think CAT selfishly for us is like very beneficial because CAT enables like a whole bunch. Like one, it allows covenant functionality, which is again, like or I guess I haven't mentioned it before, but like you can take a UTXO and then you can essentially restrict how it's spent. That just opens up like a ton of different possibilities of programmability that you can have on the base layer. But you also, with CAT, you can create what's called like a STARK, which is a type of zero knowledge proof, a STARK verifier natively on Bitcoin layer 1. So this whole thing that we spent like 20 minutes explaining, like BitVM 1 and BitVM 2 and the challenge and the response and like the operators, it's like all that's gone. Like we can
BitVM Opcat makes BitVM just irrelevant. Is that accurate?
Yeah.
Interesting. Okay, right. Juicy. Okay. Yeah. All right.
And so this is like kind of the path that like the Starkware guys like Eli Ben Sasson and those guys are kind of like pursuing and pushing for. And I think this is something that like Eric Wall acknowledges as well. So like I think that is part of the motivation of aside from that, like even people like Polstra who are like god tier, respected, Bitcoin developers are like kind of advocating for CAT because it enables like so much. It's a very simple opcode.
And by by making BitVM irrelevant, you make the entire challenger game that we just explained irrelevant, which means that the liquidity constraints and all the problems with that also become irrelevant. Like everything gets infinitely easier once you have CAT.
Yes, CAT's really badass. The main pushback I can see with CAT right now is there's this kind of like black box concern around something called like MEV. MEV, to put simply, it used to be called minor extractable value. It's now called like maximally extractable value. It's just if you're processing like transactions or running code, like the miners who order the transactions, they can order them in a certain way to benefit themselves. Maybe they can put their transaction in first, they can front run, they can back run. You can do like very, very complex, like it gets like extremely sophisticated. And if we opened up this ability to collect MEV on the Bitcoin layer 1, then there is risk that certain miners who have more resources can go out and hire, world-class quantitative analysis analysts, and they can extract more MEV. If they can extract more MEV, then they have an edge to become more wealthy. If they can become more wealthy, they can buy more ASICs, they can buy more energy farms, and then they can essentially centralize all of the mining. So the problem is that's
possible though, just like if you have more capital to start with, then you can get more Bitcoin, right? I mean, like, do you think that that's a valid concern? It feels like that's already automatically intuitive to just like, that's just already sort of built into the system. It's like, okay, if you start with more capital, then you can get more Bitcoin and you can grow faster. I mean, is this like hugely different from that?
I mean, it's tough to say. Like there is some truth to what you're saying. On the other hand, though, like we have kind of seen it in the Ethereum ecosystem that MEV is like extremely lucrative and it is extremely centralizing. And I think the MEV concerns on CAT are overblown pretty significantly, and that's kind of been made out to be this boogeyman. But I think that is like one of the potential credible barriers that is maybe blocking CAT. The other opcode, like there's tons of other Covenant opcodes. I think the other one that's intriguing is like there's a developer named Rusty Russell. He introduced this idea of like the great script restoration. And long story short, I think everybody was like, the way I see it is in Bitcoin, everybody's like, I don't want that opcode because it's insecure, or I don't want this opcode because it adds this sort of functionality. But in reality, it looked like it was just human psychology where people were like bashing other people's proposals because they weren't getting what they wanted. And I think Rusty's great script restoration, it restores a bunch of things like cat and multiplication and a whole bunch of other opcodes that Satoshi disabled. And I think a lot of people are looking at it and being like, oh, okay, with that, I'm actually getting what I want. So I'm cool with you getting what you want as well. It's just classic, like
politics.
Yeah. So Rusty's kind of like investigating a bunch of that right now, and like hopefully in the next year or two he comes out with some sort of analysis that says, hey, this is all legit, it's clear, and like we can get consensus around that.
Nice. That's actually one of the more balanced ways to think about OpCat that I've heard, that like there are actually some legitimate concerns about MEV centralization, but that like maybe they're a little overblown, or that maybe they're would you, is overblown a word you're going to stick with?
Yeah, totally. Well, like, okay. And feel free to pause me if you want, but like, there's kind of two potential sources of MEV. There's like if you have this cat verifier and like we get rid of the whole BitVM game and then we have the L2s, like, sure, there could be tons of MEV that happens on the layer 2, but all of that's captured by the layer 2. It doesn't like bleed down into the layer 1. So that's not an issue. The issue is like people say like, well, with CAT, maybe you can make like an AMM, which is just a way to like perform swaps. Like you trade this token for this token or this ordinal for this ordinal on the Bitcoin layer 1. And because you can do trading on the Bitcoin layer 1, that's where you could extract some sort of MEV, and that actually goes to the miners, which causes centralization. The criticism of that is like, dude, like maybe you can build an MEV, but like this thing would be horrible, like like absolutely horrendous. And like nobody in their right mind would actually use this thing, let alone at scale. So it's like, if you could create an MEV and could like miners in theory extract like some amount of MEV, I guess, like what would they extract? Like hundreds of dollars? Like great. Like they could just go sell t-shirts with like their logo on them. Like for MEV to be legitimate, like it has to be things that can gain like mass amounts of usage and scale. And just even if you add this kind of programmability, this light programmability on Bitcoin layer 1, like you still have like the block times, you have like the block space, you have like the limits of like the stack size. Like there are so many other things that kind of restrict you from like building these applications at scale to where they actually become like a material issue, in my opinion. But there's other smarter people that understand this better than me, so I'll let them handle it.
Okay, so it sounds like you are like pretty pro OpCat. Is there another opcode for covenants that you would prefer, or would OpCat be your first choice?
Yeah, I mean, I don't want to take a strong position on this because like I'm not as well informed on the rest of the covenant proposals. Enough to be dangerous, not enough to probably take a strong stance.
Fair. All right, cool. Okay, well, that like definitely answers that question. I feel like this is now just becoming part of my regular podcast routine, is like, where does everyone stand on CAT? Yeah, we're gonna have Tyler Whittle on soon, and hopefully Udi and the gang, and we'll grill them all. But yeah, it's sort of interesting to get everyone else's point of view. Yeah, so I'm starting there.
I hate to say it, but like I think OpCat would have more traction if Udi and those guys just weren't a part of it.
Would OpCat even exist without him, though, right? I mean, that's sort of the other side of the equation. He's such an effective, he's polarizing, but it's sort of like Trump, right? He's sort of like the Trump of Bitcoin improvement proposals or something. And I think it's probably, he's net winning. I don't know if we would even be talking about OpCat if it weren't for Udi.
I mean, the problem is it's like, it's not like an election where like you need to get like 50% or like all the electoral states to vote. It's like you need like an obscenely high bar. And there's so many people that have just like Udi and Eric derangement syndrome.
Okay, I think that I need to tweet about Udi Wertheimer derangement syndrome. That's going to be a tweet. I'll credit you though.
Very real, very real.
Oh my gosh. Well, thank you so much, David. This was so fun. Yeah, there was like lots to like dig into. And this is a really complex, challenging topic. I try to make my podcast as sort of accessible as possible for people, but like
Yeah.
sometimes you just got to go in at intermediate, like that's just sort of where we're at right now. So anyone who's still listening to this podcast at this point, like consider yourself at least intermediate. Good job.
Yeah. Yeah. Great.
Um, yeah, cool. All right. Well, thanks, David. Yeah, I'm going to press pause and this was awesome. Talk to you soon.
Thanks, Isabel.